log, in general, we have to have in the back of our minds at all times log properties. If this way looks weird, then write it like this. Because this is one of the properties of log. If log is applied to an expression with the power goes in front as a factor. So the whole thing reduces to 1/2 the integral from dx x natural log x. So of course, from all this, natural log is the one requiring, so let's say u.
You're still sharing the screen.
I am, sorry. Okay, so the integral, so let me start from scratch, sorry. So dx over x natural log x squared. So whenever we look at properties, we deal with log in any base, we always have to have the log properties in the back of our minds. So if I have this situation, then this is basically 2 natural log x. So I have 1/2 that goes outside, the x at the top, x natural log x. So I'm going to denote u natural log x by u because du is 1 over x dx. And this is it. This is my du, and this is my u. So everything is accounted for. So then from here, I continue here, and I have 1/2. So it's du over u, which is 1/2 natural log of the absolute value of u plus a constant c. Yes, I have to plug in the substitution because this is an indefinite integral. The answer has to be given in the variable that the function is in. So the function is in variable x, the answer has to be in variable x. So this will be 1/2 natural log of the absolute value of natural log x plus a constant c, and this is it. And remember, the indefinite integrals, we can always verify. If I differentiate this, I have to get 1/2 x natural log x rewritten as 1 over x natural log x squared. Is this okay?
Yes, thank you.
Anytime. Other problems? Did we work on anything else? Did we have anything else? Anything? Okay, you can always stop me. So I'd like to go back to 5.1. So in 5.1, again, we looked at consumer surplus and producer surplus. So depending on what we are looking at and which, if we're looking at the equilibrium point, if we're looking at a particular point, it doesn't matter. You remember the formulas. This is the integral from 0 to a number, depending on the point we are looking at, of d of x dx minus that area of the triangle, of the rectangle, I meant to say, of course. And this one is the area of that rectangle minus the integral from 0 to a number from s of x dx, where this is the demand and this is the supply. And how we got this? Remember, from those areas under the curve of consumer and producer. In other words, demand and supply. So this is what we are applying. And we only looked at one problem last time, so I'd like to continue. Not sure which page was that on. 5.1. I'll find it. 5.1, page 454. So let's go to 454 and practice. I remember we did a problem from here, abstract. So we were asked to find the equilibrium point, part A, and the two numbers, consumer surplus, the value added, the utility, if you want, for each. So we can choose anything else if you'd like from here, but I'd like to move on to problems, word problems. They use the same thing. So this problem really involves everything. So consumer and producer surplus and the equilibrium point and a different point. So I think this is a good indication of what we're trying to do. So if you're not happy with 15, we can choose something else. If 15
sounds good.
Okay, then let's start with 15. This is my page 2. Okay, so Beth enjoys skydiving because this is also will give us some insight in what we're trying to do here with the consumer and producer surplus. In other words, the idea is for the consumer surplus, the more units we purchase, we are supposed to purchase at a lower price. So we get a value added to it. But again, as I said last time, don't go out and buy 10 cars and etc., 10 computers, etc., etc. Okay, so let's look at 15, and this is on 455 in part A. Let's see. So she enjoys diving and is willing to pay P dollars per jump for X jumps. So this is the demand, 7.5x squared minus 60.5x and plus 254. Find her consumer surplus if he makes 2 jumps. So once we're told that she makes 2 jumps, this is the number of units. So remember, this is the number of units, and this is the price per unit, right? So I have to determine the point right here, number of units price. So the point is, when x equals 2, I have to determine d of 2. So this is x and this is y. So first I determine d of 2 as 7.5 times 4 minus 60.5 times 2 plus 254. So let's see what that is. I have my calculator ready. I guess almost. Okay, so 7, what if you give me is this number? If you have it, don't torture me. So minus 60.5, because you can punch it in much faster, and plus 254.
405. Oh, never mind.
That's okay. I make mistakes too. I'll be more than happy to check. I think I'm okay on this one. So 163. I immediately, that's okay. Sometimes we have to be very careful with the calculator. When you first start it, it may not even take the first digit you enter. It happens to me very often on the regular calculator. Okay, so I need to multiply this by 2 right away. Why by 2? Because remember, that's the area. So the area here, this rectangle, will have the area 2 times 163, and that was 326. So now to determine the consumer surplus, we have the integral from 0 to 2. So this is the 2 in here, and this is the 163. So from 0 to 2, from dx, d of x dx, and minus this area, 326. So what I would like you to do for definite integrals, normally I don't show this because not all have this calculator or this capability in their calculator. So at this point, I need everyone to write this. And yes, I will show you how to determine this without plugging in numbers. I also need you to just at least show that you're plugging in 7.5 times 8 over 3 minus 60.5, 4 divided by 2, plus 254 times 2. When you plug in 0, you get 0, minus 326. And all this can be calculated directly with a calculator. So let me share my screen. Be very careful how you enter. So I haven't checked here, but let me see, it should be, yes. So you have number 9. That is a feature of these new calculators. It's not in the TI-84 old calculators or 83 old calculators or 81 even. So select number 9 and see it gives you all the information for a definite integral, which is from, in this case, from 0 to 2. of course, you make sure that it's x, dx, right? And now the function, remember, you are not entering the antiderivative. You are entering what you see in your integral. So 7.5 times x squared and minus 60.5 times x and plus 254. And you can even go outside and already subtract your 326. So we get $81. So when she chooses to do 2 jumps, her value added, the extra she gets without paying for it, it's 81, in the value of $81. So now the producer surplus is, careful, this is not the equilibrium point. So this area will be different now for d of x, because I forgot to copy d of x. Okay, so suppose this applies such and such. So part B, we have s of x, which is 15x plus 95. So again, for 2 jumps. So I need to determine a new point for a new function, because this is not the equilibrium point for this function. So when x is 2, s of 2 will be 30 plus 195. I think it's 125, right? 2, 30, 125. So the new point is 2, comma 125 for this function. And the product, or the area if you want, will be 2 times 125, which is 250. So now this is 250 minus the integral from 0 to 2 from this function dx. So 15x plus 95. And from here, I'll move on to the next page with the square. And we have 250 minus 15x squared over 2 plus 95x from 0 to 2. And we plug in. So it's 15, and this is 4 divided by 2, and plus 95 times 2. Yes, I'm fine if you plug this in the graphing calculator, as I showed you. And as I said, I normally don't like to show this because not everyone has this calculator, and it's an advantage. So for others versus everyone else. So, but okay. So be careful what you're entering. You're not entering the antiderivative, right? You're entering the integral. Okay. So that was 15x plus 95. And then I press enter. And this is it. So what does this mean, the $30? It means that we're paying for, or she's paying for 2 jumps. But according to the actual cost, or what is the value added for the producer this time, she's paying 326 for 2 jumps. But the the producer is really not giving her, or the producer is getting extra of the $30 as utility for them. Okay, now let's see. Part C is the whole thing. They want us to consumer service assume that the Beth. So this is a key phrase. Assume that Beth makes no more than 5. So we have to find the equilibrium point and redo the consumer surplus and producer surplus for that particular point, which is a totally new point. However, what is nice about it is that the area for the equilibrium point, this area as well as this area will be the same. Here they depend on the function, but when we find the equilibrium point, both functions will have the same height. I mean the same area, because it's only one x and only one y, not two different y values. They will be the same. So this area and this area will always be the same at the equilibrium point only. Okay, so first let's, in part C, let's find the equilibrium point. By, how do we do that? Anyone would like to help?
Do they have to equal each other?
Exactly.
The demand equals the supply.
Exactly, that's it. The equilibrium point is d of x equals s of x. And d of x, I'm copying it. And this is 15x plus 95. Okay, so I will move this around, so negative 75.5x, and plus when I subtract, this is 9 from 4 is 5 and 1. Correct my numbers always. Okay, so at this point in calculus, I'm fine if we simply go to the calculator and use that feature, which honestly I didn't even know that this calculator had. I think you showed it to me. Where is it? No, it's in apps. Okay, so it's 9. I was always going back to my own calculator. T86, the old one, that they don't want to produce anymore for whatever reason. Okay, and this is negative 75.5. So I'm fine. You don't have to even say I use the quadratic formula, or you can, just to make sure, and solve. Okay, so the problem is telling us no more than 5. So this means nothing to us. I will copy the two answers. X1 is 3 and X2 is 106 over 15. But I will say X has to be less than or equal to 5 as stated in the problem. So that's